Hi everyone and welcome to CoderDojo HAM's Christmas special, a Python marathon festive feast for you. To get straight into it, handing over to Aya to help you decode the mysteries of Advent of Code. Over to you, Aya.
Thank you, Peter. Hi, everyone. So I'm Aya, and today we are going to be taking a look at some programming challenges in the platform we're going to be using is the Advent of Code 2020. It was briefly mentioned kind of in the last session that you would have seen last month. Advent of Code is a yearly set of programming challenges. We have 25 days of challenges, 2 challenges a day, and we've had them for the past 5 years. So currently there are 250 challenges for you to be able to tackle. And we're going to be taking a look at some of those today, some of my favorite ones from 2020. So the first thing you're going to need to make sure you've done is gone to adventofcode.com, and you'll get taken to this main page here where you can log in. You can authenticate with Gmail or GitHub or even Reddit if you use that to create an account. And it's important that you have your own account, because the way this works is it gives you a unique set of input data, which you then manipulate and use in some way to create an output. And when you get the correct output, you receive a star. The reason I'm doing this is because, of course, programming as a whole, one of the most important parts of programming is creating code to solve problems, create solutions, and fun challenges like this, as well as being fun, because who doesn't love a bit of a challenge, is great practice for really drumming in those fundamentals of programming and coding. And we're going to be using Python 3 for that today. So if you didn't already see it on the CoderDojo YouTube channel, Richard made a fantastic video covering day 1 with Ozzy. I do recommend also giving that a watch. It really helps you get into Advent of Code, understand the concepts behind it, and demonstrates, of course, a bit of the submission process. But for now, I'm going to go into day 3, which is the day we're going to be looking at, first of all, today. So this is what the Advent of Code looks like. It gives you a set of instructions, and you have to follow these instructions and manipulate some data in order to create an output. I'm choosing this one because it's quite a nice one to begin with. It's not just a bunch of numbers and letters. You actually have a map here, and this map is of a toboggan slope, or a sled slope. And we need to get down this slope and count how many trees we crash into on the way down, which is always going to be a little bit painful, but let's see how that goes, shall we? So the first thing we need to look at is our map here. This is a sample input provided by the Advent of Code. Everyone will see this exact same sample input. So it's a good one for practicing your code against, because then it also gives you the answer that you're looking for to make sure you're creating code that meets the specifications before you use your own personal set of input data. Thank you, Richard, for dropping the Advent of Code link in chat. This is day 3 that we are currently looking at right now. So, day 3, yes. So, as well as this, we're also provided with the instructions that our map will infinitely repeat to the right, like so. So this map that we're looking at here is just this map tiled infinitely to the right. So when we get given our map, we can assume that should our character leave this right side of the map, we actually keep going down a repeated pattern of the map. And we start in the top left corner. So the first thing it's going to ask us to solve is what it looks like when every time we go down the slope, the angle we're going at is at 3 units to the right. So 1, 2, 3, and 1 unit down, meaning we will end up here. And then again, 3 units to the right, 1, 2, 3, and then we go down. And because this is a hash, that means we crash into a tree and we count that tree. And we need to go through all of this in order to of course, count how many trees we hit on our way down the slope. So without further ado, let's jump into Trinket and begin programming our solution. So the first thing we need to do is actually have a separate file. And I'm just going to call it input.txt. It's probably the best way to go about it, since it's a set of input data, and the text raw text format will, of course, work. So we're going to paste the map into this like so, that we would have copied from here. So now we have our map in a text file. And the first thing we need to do before we can start navigating our way through this map is actually load it into our program in such a way that it's readable by the code. And we are going to do this with a really nice little bit of list comprehension, which is one of my favorite tools in Python. I'm first of all going to go about this the more naive manner, and then, of course, demonstrate a list comprehension method of doing so. So the first thing we're going to do is read in our file, and we're going to create a file called variable, and we're going to open the file input.txt as the first parameter to the open method. The second parameter we need to pass in are the permissions that we require in order to access this file. We can have read permissions, write permissions, read-write permissions, but for now we only need to be able to read the map. So we're going to pass in the string with the character R, and that is quite simply, can I zoom in? Absolutely. Please tell me if this is better. I've zoomed in a bit on that now. If you can, please tell me if that's better. And then, thank you. Fantastic. I'm really sorry about that. So we are zoomed in now. You should be able to read that nicer. Okay. So we have our file variable, and we're opening into this the input.txt, which is our map here that we've pasted in, and we're reading it in with the read variable. And the next thing we're going to do is pass a method onto this, which is the read lines method. And this will create an array of all of the lines in our text file. So now if I print out our file, we will print out an array of all of the lines. Now, this isn't perfect. This isn't exactly what we want yet. We're going to work on that in just a moment. But we now have an array of all of our lines, and these /n's at the end are the new line character, which is where it goes down to a new line. So what we need to do now is create another array, and we're going to call this map. And this is going to be an empty array. And now we're going to iterate over our input file. So for line in file, which is going to be a for each loop. And every time we iterate over, line is equal to one of these lines in the array. We're going to map append. We're going to append the line to the map, but we're going to replace our new line character with some blank text. So now when we print out our map, we will have an array of just the lines. And if we do a for each for line in map, if we now print out each line in the map, we will have a nice output of our map here. Now I'm going to do this with what's called some list comprehension, which again is one of my favorite tools in Python. And the first thing we're going to do is create a variable called map. And then we're going to open up our square brackets to create an array. And we're going to create a generator object using list comprehension. So we're going to say line.replace. Replace our new line character with a blank character. For line in open input.txt.readlines. So this really long line of code here is a piece of list comprehension, and this will generate an array which will look exactly like what all of this code up here just did. So if I just comment all of this out, bring our list comprehension up to the top here, and then run the code, we will see we get the exact same thing, but this runs a lot faster and a lot more efficiently. It's saying we're creating an array, and it's going to be line.replace the new line character with blank for every line in the array, which is generated by opening our file as read lines. And this would usually create just a generator object, but because we are wrapping it in some square brackets here, we are creating a lovely little array that we can then iterate over. And we're going to be doing that again for the next puzzle that we do. So now we are through the first part of this. We now have a lovely map that we can iterate over, that we can navigate through in order to start going down the slope. So the next thing we need to do is create some variables that we're going to be tracking for the course of this exercise. So the first thing we're going to want to be tracking are the X and Y coordinates of our character. Go a little bit slower? Absolutely. Yep, no problem at all if I'm moving a little bit too quickly. So now we have the array, the map, of course, of our map that we've read in, as a nice a little array here that we can navigate over. Is everyone caught up with that, or does anyone need me to go over that again before we move forward, just to make sure? If anyone needs me to navigate over this again. Okay, so I'm going to, almost there. Okay, so I'm going to bring back onto screen this part here. So you can just use this bit of code here, and it will functionally be the same as this list comprehension here. So I'll let you look at that for just a moment, and I'm going to start creating some variables that we're going to be tracking throughout the course of this challenge. So the important thing is knowing where we are in the map, because we're going to be navigating down the map. So we start at the very top left, which means we start at X position 0 and Y position 0. So we can create those variables like so. We are at X position 0 and Y position 0. Now we need to track exactly how many units we are moving on each iteration. So as the exercise told us, if I zoom in here, the exercise told us we're going to be going right 3 and down 1 at every loop. So I'm going to go right down, and we're going to go 3 to the right and 1 down. And that will, of course, allow us to track that later on to know how far we're moving. Now we need to understand, how do we know we're at the end of the map? And if anyone wants to give a suggestion of that, how will our program know that when we've reached the bottom of the map? And I'll let you think about that while I just create another variable here called trees, and that's going to be tracking how many trees we hit. So we want to have a goal, and this goal will be able to tell us. Can I scroll to the right? Right, okay. What is it that you need to see? Right, this part here. Okay, if I just zoom out just a little bit here for you, you need to see that. Okay. So the goal that we're going to be seeing is the length of the map. Our array, which is our map, has a length that is equal to exactly how many lines that we have. So if we have how many lines are in this? 11. That means when we hit line 11, we've hit the bottom of the map. We know that because that's what the exercise has told us. So our goal is the length of the map. Okay. Now we need to start looping and iterating over our map to know where we are. And that means we're going to be using a while loop. And again, we know we've finished the exercise when we get to the bottom of the map. So our loop will finish when our y is equal to our goal. So while our y is less than our goal, we're going to be still moving down the slope. So that's what this while loop here is going to accomplish. So as long as our y-axis is less than the goal, which is the length of the map, we will keep iterating over and keep going down the slope. So the very, very first thing we need to do is check if the current square of the map we're on is a tree, because if it's a tree, we need to count that tree because we've hit it. So the first thing we're going to do is check what the current square is. So we're going to make a variable called current square, and our current square is going to be map. It comes with a red message saying traceback for line file not found error. That means you haven't created an input.txt file, which was the first thing we did here. So you at the top right of your trinket, you hit this little plus icon here, create a new tab called input.txt, and paste your map in. You're getting that error because it cannot find the map. So you need to paste that map in there to make sure it can find it. Otherwise, it won't have anything for it to read from. So the first thing we need to do now is consider how we look at our current square. Now, our current square, the first thing we need to know is when we are looking at our array, we are looking at an array of strings. So each string is each line of the map. which will be our y-axis. So the first thing we need to do is select the line that we're currently on with our y-axis. The next thing we need to do is select the current square that we're on in the columns here, and that will just be with our x-axis. So right now, our character is at 0, 0, so that's map row 0, column 0 is what we're doing there. And now we need to test what the current square is. So if our current square is a hash, which is this cool little symbol here, then it's a tree. So that means we just need to increment our trees counter by 1. Just like so. So let me zoom back in on that a bit more just to make sure you can see what we're doing here. So now, if our current square is a tree, we're going to increment our trees counter here by 1. So now we've checked if it's a tree, we need to now move our position. So we need to move our x position to start with by the amount of squares we move to the right, which we defined up here, which is 3 in this example. And then now we need to move our y position by the amount that we move down. So now, is there a way you can access the code so you can compare it to mine? I could probably share my code with you. Let me just... I don't know if this is going to work. This is my code. I've just linked it in the chat for you, Mr. Magma. So that's my code if you'd like to compare it with your own as it stands at the moment, if that helps. Okay. So now we have a while loop, which is saying while we are not at the bottom of the slope, look at the current square. If that square is a tree, count our trees by 1. Now we move our player to the right and we move our player down. Okay, now if I run this, I am going to get an error. Now, can anyone tell me why they think I might be getting this error? Because I have not yet done one very important part of this exercise that was covered here. Can anyone maybe guess why we're getting that error before I move on? What have I not done yet? If no one knows, that's perfectly fine. I can, of course, just say. No one seems to be saying, okay, that's perfectly fine. So the problem is we are moving down our slope like so. We're going 3 to the right and 1 down. So now we're here. Then we're going 3 to the right and 1 down. And now we're here. Then we're going 3 to the right and 1 down. And now we're here. And then we're going 3 to the right. But wait, there's no map there. So we're trying to go to a portion of the map that doesn't exist. Exactly. We haven't finished adding all of the trees. Now, there are 2 ways we can handle this. We can either create our map to be really long and just have a very long map that we can continually go down, which will create a huge set of strings, lots of strings, or we can introduce a wraparound, which means when we leave the end of the map, we come back on the other side. So as if we are looking at our map up here, as we go off to the right, we come back over on the left-hand side, like you might see in old video games that you might play. Wraparound is very heavily implemented because it's efficient. So we're going to, first of all, check if our character is off of the map. And we can do that by saying if our x position is greater than or equal to the length of the string, we know that we are off the map. Because if our string is of length 10 and we are at index 10, we are too far off because the highest index there would be 9 because remember we start at 0. So we're going to be going off to the right. So if our x position is larger than the length of map 0, and that's saying the first line of the map, then we know we are off the map. So now we have to bring ourselves back onto the map. Now we could just say x equals 0, but that won't quite work out because if we go 4 squares after the right, that will put us back at the first square on the left. Instead, if we go 4 squares after the right, we want to come back to the middle 4 squares in. So we're going to do that by simply saying x minus equals the length of the map. So if our map is 10 squares long and we go to square 14, we're going to take 10 off that and bring ourselves back to square 4, meaning we come back to a position in the map relative to how far off it we went. And that's going to make our player wrap around. Now, if I run this, we're not going to get any errors. And now we have a variable called trees that will tell us exactly how many trees we've collided with on the way down, hopefully. So we're going to print a string, and this string is going to say we have collided with curly braces here. This curly braces will be formatted to represent our amount of trees hidden. We have collided with trees on the way down the slope. Okay, and then at the end of this string, we're going to do dot format, and this will now give us, if we type in the trees variable here, it will format these curly braces here with our amount of trees. So if we run this, we will see we have collided with 7 trees on the way down the slope. So if we go back to look at the exercise, it will actually, because this is the sample input, this is the test input they want us to work from, this will now tell us how many trees we hit in this sample. And it was 7. So we now know that in this sample map provided by the advent of code, on our way down, we should be hitting 7 trees. And if we look at our result here, we have collided with 7 trees on the way down the slope. So now we have working code. So our last thing that we need to do is take a look here and type our answer into this box, but it won't be correct yet. We have to first get your puzzle input with this link here. And this will take us to a page which is unique to each player. And you can see we have a very big map on this page. But if we just copy all of this map and paste it into our input, if our code has been written well, our code should work also with this input as well as it worked with the sample map. Your one doesn't say 7 trees, it says, did you do the dot format at the end here? So you need to make sure at the end of your string, you do dot format. Yeah, so you need to make sure you do that. There you go. Okay. Wonderful. I'm glad you're there. Okay. So now you have 7. You now have your string telling you you're colliding with 7 trees on the way down the slope. Now the first thing I'm going to do is comment out our bit of code here, which is displaying the map. Just because we don't need to see the map anymore. Our map is here. We've taken our map from the advent of code and we have pasted it into our input.txt file here. Now the last thing we have to do is run our bit of code and see what the result it gives us is. On my result here, I have collided with 151 trees on my way down the slope. Now, you might have a different number. You might have the same number if you've got a map very similar to mine, but it's different for every player, which is why you need to have your own account. So in my input here, we have collided with 151 trees. Doesn't quite work yet. Can I share the last string? Absolutely. This is the last string. Scroll to the right. Yep. Sorry, I realized I was cutting it off a bit there. Okay. So hopefully you can see that. Hopefully you can now see how many trees you collided with on the way down the slope. And if you were using the sample input that you pulled from the advent of code here, it should say you hit 7 trees. Okay. So now you need to, like I mentioned, go to the bottom of the page and click the button, get your puzzle input. And this is the crux of advent of code. You have your own unique input that you copy and you paste it into the input.txt like so. And you now use this bit of data to actually get your puzzle solution. So again, I'm going to run that, and I'm hitting 151 trees. You might be hitting more. Hopefully you're hitting less. We don't want to be hitting too many trees on the way down the slope. But if I now go to the advent of code and I type 151 into here, hopefully I get the star. So that's the right answer. You are 1 gold star closer to saving your vacation. If you got 252 trees, try putting that into the advent of code and see if that worked for you. Like I say, it'll be different for everybody because it's a unique set of puzzle inputs. So you won't have the same answer as me once you actually use your personal input. But if you type your answer into the advent of code, you should get a lovely gold star like so. So now we have our first gold star on our puzzles page. Okay, so that's happening, Zeneb. Can I post the code? Okay, I will share my code again. Let me just share this with you. So that's happening, Zeneb, because you are doing the print statement within your while loop. So you have a while loop here that you're iterating over. And if you tab your print statement over here, you will see it a lot of times. You need to make sure that this exists outside of your while loop, so it can't be indented. So that then will only say it once. It's happening multiple times because at the end of every loop right now, you're doing the print statement. Does that make sense? So now we can see exactly how many trees we've hit on the way down, and hopefully you will now all submit your solutions and get your stars, hopefully. I am going to move on now to the second part of this puzzle. I've posted the code in the chat for the link to my code, so you can keep looking at that for part 1. Well done, Zeneb. You got your gold star. Fantastic. I'm glad to hear it. Okay, wonderful. So that link is the link to that bit of code is in the chat. Now we're going to look at part 2 because it doesn't just end like that. It also has a second part to the puzzle. Now the second part to the puzzle is we need to go down our slope 5 times. And those 5 times are indicated here with the angles we need to take down the slope. Right to the 1 and down 1, right 3 and down 1, right 5 and down 1, right 7 and down 1, right 1 and down 2. So we need to go down our slope 5 times, count how many trees we hit on every single time down the slope, and then multiply those answers together. So the first thing I'm going to do is get our sample input again, because again, this will give us the answer. We will know if we have the correct answer once we do it. So now we need to think about how we're going to go about this. Well, we know we need to go down our slope 5 times, which means we have to do all of this code here 5 times. But what do we tell it to give it the angles? So I'm going to create a new array here called slopes. And our slopes here will just be an array. And it will be an array of tuples. So I'm just going to get these lines here and comment them into my Python here, just so I can see them. So these are the angles we need to take down the slopes. So we need to now write these into our array here. Congratulations on getting a gold star. Well done. That's your first gold star in your journey to purchasing a hotel for your vacation away from the North Pole. If you do follow all of the challenges for Advent of Code through the order of the days, it actually tells a really cool story. Every year the story is different, and it is a very fun story to follow. Well done, J. Coder King. Fantastic. I'm glad to hear you're all getting your stars now. That's great to hear. Well done. So now we're going to take a look at the second part of the puzzle. So we need to create an array here, and this array will contain all of the angles for each slope. So our first one is going to be right 1 and down 1, just like so. And now we're going to create another tuple, and this is going to be right 3 and down 1, just like our bit of code here tells us to do from the exercise in the Advent of Code page. Our third tuple is right 5 and down 1. Our fourth tuple will be right 7 and down 1. And our last tuple is going to be right 1 and down 2. So this now is an array of tuples containing all of these slope angles that the Advent of Code has told us we need to be tackling. Okay, So now using this, we can use a for loop over these slopes. So the first thing we're going to do is say for slope in slopes. And this will create a loop that iterates over our array of slopes here. And on every iteration, slope will equal each tuple. And now we're going to take all of this code here that we made for just one slope and just indent it once, like so. And now this set of code will run 5 times, one for each slope. However, our right and our down angles need to change each time. Our right angle, you could have created a function taking a slope as an input as well. Actually, that would also be a great way of doing it. That is also another fantastic way of handling this, especially if you get very, very large amounts of slopes. You can then, of course, create a function that takes a slope as an input, runs through all of this, and then iterate over the slopes, of course, to do that. That is another way of doing it. It's not the way that I'm tackling it right now, but that is, of course, an extremely valid way of doing it as well. And it's actually the way that I handled it when I first did this exercise. So yes, if you would like to do it that way would also work. So now we need to do is we need to make our right angle equal the first value we pass in, which is going to be slope 0, like so. This will mean that when we look at each slope, it will be the first one. So we go right, and then our down angle will equal slope 1. So now we have 5 slopes. And if we go over, we will, for every slope, go down our hill, go down our map, with our right and our down angles pulled from the tuple, and count up all of the trees. However, we now need to actually store these trees somewhere. So we're going to create another variable here called trees hit, and this will also be an empty array. And at the very, very end of our for loop, after this while loop, at the end of every for loop, we are simply going to say trees hit dot append trees. So that will run down our slope with the angle given, count how many trees we hit, and append that value to the trees hit array here. And then move on to the next slope and do it all again. And we will now, if I print out our trees hit array, we will now have an array of 5 numbers. On each slope, we hit 2 trees, then 7 trees, then 3 trees, then 4 trees, then 2 trees. If we check the Advent of Code page, we should see that 2, 7, 3, 4, 2 are the answers we expect to be seeing there, which means we are going down the slope at the correct angles and hitting the correct number of trees. Ouch. Okay, so the last thing we need to do now is do the last part of the exercise, which is we need to multiply all of the values of the trees together. So, for instance, we have the array here. We need to do 2 times 7 times 3 times 4 times 2 is the piece of math we need to do here. So there are a few ways we can do this. We can iterate over the loop to an output value and multiply it all together, or we can use a NumPy module. What does this mean? Sorry, what does what mean? And I can answer the question, sorry. So this array that we're looking at here is the amount of trees we hit on each of the slopes that we ran down. Our Advent of Code puzzle is giving us 5 different angles to go down the slope. And we're going to go down the slope at each of these angles. So for each angle here, your problem. Sorry, I can't see what your problem is. Oh, did I break up? Okay, I'm really sorry about that. I will link the code as it stands into the chat right now. Oh, so to show this array here, all you had to print was the trees hit array. So if we print the trees hit array, like so, we will then get the array of trees that we hit. But what we need to do now is multiply all of these values together. And the way we're going to do this is by importing NumPy as NP. NumPy is a fantastic Python module you might have used in previous sessions that lets you do really quick maths and data science on arrays very, very quickly and easily. So we're going to import NumPy as NP like so. And we are going to say our final trees hit will equal np.prod, which is the product of all the values of an array, and we're going to pass in the array trees hit, just like so. So what this is saying is take the trees hit array, multiply it all together, and then assign it to the final trees hit array, just like so. Okay? And then we are going to print that out. So now we're going to, in our print statement here, change our format statement at the end here to be final trees hit, just like so. I'll move it over to the right for you. So now we are taking our array of trees that we hit on the way down the slope, multiplying all of the values together, and now we're going to print that out in one lovely print statement, and we hit 336 trees on the way down the slope. So if now this is the final code, so I'm going to relink the code one last time in chat. And this is the final bit of code that you need. Just like so. So now we need to go and make sure 336 is the correct answer for our sample input, which it is, which means our code is working for the sample. So now we're going to get our puzzle input once again, and we're going to paste that back in. So now we have our input data in our program here. So now hopefully when we run this code, we will get a very big number of all the trees we hit on each slope down our map. So let's try it. We have a very big number here. This is nothing comes out at all. Are you making sure that that you're uncommenting the print line? Because we did comment out the print statement earlier on. Are you making sure that it's not commented? So if it's like that, it's not going to work. You need to make sure you've got that print statement and it's not commented out. You did it. Fantastic. So on my solution here, we are hitting 7,540,141,059 trees on the way down the slope. That's a lot of trees. We are going to have quite the headache after this. Let's paste this into our answer here and see if I get my second gold star today. There we go. There's our second gold star. Can one of the presenters just tell me how long I have left? I think I have about 20 minutes left, but I might be wrong. Okay. So that's it. Now we are going. So is everyone getting their second star here? So, yep, we have 2 people with stars, 3 people with stars. Wonderful. We are getting our stars. So that's fantastic. We're all now getting our second stars with our lovely bit of code here that lets us go down the slopes and count how many trees we hit, which is a lot of trees. Okay, so my plan was to... Your one does not work, Zinab. Okay. What's it saying? And we can help you try and fix that. What's it saying? 20 minutes. Okay, thank you, Richard. So the last bit of code that I linked will be the working piece of code for that. I am going to move on to the next exercise. However, if you still need help getting this star, please ask one of the mentors in chat, and I'm sure they'll be happy to help you go through that. But I do need to move on to our second exercise because I am running out of time here, unfortunately. So next we're going to be looking at day 5, and this is one of my favorite days. Now, this is utilizing some... Can you paste that into code link in chat? Absolutely. So Let me just get the link for you. Okay, so now we're going to be looking at day 5. Day 5 is we are on a plane and we can't find our seat. We've lost our boarding pass. So we write a quick application on our phone to scan all of the boarding passes of every other passenger on the plane. And the boarding passes are formatted like this, where every letter means either front, back, right, or left. So F means front, B means back, right means right, and left means left. And we're going to use some binary sorting to take a look at to find out where our seat is. So before we actually go forward with that, I'm going to visualize this a bit here. So this is how this is going to work out. Let's say that this is our plane, just here like so. I'm not the best drawer, so please bear with me. And let's say we have 8 seats in each row. Okay, so there's 8 seats in our row here. I'm actually going to make these all straight lines just for the sake of continuity. Okay, and let's say we also have 8 columns. So each of these red lines is a seat on the plane. Let's quickly get this made. I'm not the best artist. Okay, so let's say each of these red lines is a seat on the plane, and then this is the front of the plane over here. This is day 5, Coder person. Let's say this is the back. That would mean this is the right, and this is the left. If the boarding pass, if the first letter is F, that means we take the front half of the seats. So it's not going to be in the back half. The seat is going to be in the front half of the seats, like so. Now let's say the next line on the boarding pass is B. It means from the available ones we have left, we take the back half, like so. So it'll be this back half just here. And let's say it says B again. That means we take the final back half, which is here. And that means we know we are sat in this column of seats. Now let's say the boarding pass says R. We take the right half of the seats. If it says R again, we then take the second right half of the seats. And if it says L, that means it's left. We take the left half of the seats, meaning that this seat here will be the seat on that boarding pass. We then need to work out the ID of the seat. So this seat is in row 3, column 3, and it's in row 1. So in order to work out our seat ID, we do the column, which is 3 times 8, and add 1 to that, which will be 17, which means our seat we've just found here is seat ID 17. So we need to now go and do that for all of the boarding passes in our input document. So let's do that. Let's first of all take FB, FBB, FF, RLR. 25, sorry. Is it 25? My mental math is bad. Okay. I gotta remember now. 3 times 8, 16 plus 1. Yeah, 24. Yeah, 25. Well, this would be row 3 because they are 0-based. So 3 times 8 is 24 plus 1 is... This is row 3 because they're 0-based in this exercise. So this is row 3, row 1, column 3. Yeah, so that's what we need to remember. We start with 0 when we work in these exercises. And this would be not 17, 25. Thank you for the correction there. Okay. This is a boarding pass here. And we now need to open up this boarding pass as a list of passes. So we're going to say passes equals, and we did this last time, so just use the code from last time as an example. We're going to quickly read this in here. For line in open input.text r. Read lines. Okay, so we did this last time. This is the exact same little bit of code that we had. So now if we print our passes out, we will see that we have read now our pass into it here. And if we had more than one pass, so let's just grab another pass from here. If we now print this out, we will have 2 passes. The ID would be the same for 2.9, you're correct. Okay, so now we need to actually start figuring out where each seat is on each of these boarding passes. So first of all, we're going to create, and the reason we need to do this is we need to find every single ID of all the boarding passes in our document and work out what the highest one is, okay? So first of all, we're going to create an empty array called seat IDs. And this is where we're going to be storing all of the IDs that we find for each seat. And now we need to iterate over our passes array. So I'm going to say for p in passes, if we were to print p right now, we would get each p now is equal to each pass in our input.txt document. So the first thing we need to do is figure out what the rows and the columns numbers are. Now, our exercise tells us here that our rows are numbered 0 through 127, and our columns are numbered 0 through, I think it was 0 through 8. I'm struggling to find it now. 0 through 127, and our rows is 0 through 7, yeah. So we have 127 rows and 8 columns is how many seats we have here. So a nice and fun way to do this would be to create an array of all of the seat numbers in each row. So that's what we're going to do. The first thing we're going to do is create an array called rows. And we're going to again use some list comprehension here. We're going to say rows I for I in range, and that will be 128, which will give us an array containing the numbers. If I just print rows out here, we now have an array containing the numbers 1 to 127, which is what we want. And now we are going to say columns. We're going to do the same thing. I for I in range. And we're going to say 8 here. And this will give us a nice little array of all the numbers from 0 to 8. So, or 0 to 7 even, because it's not inclusive. So now if I print rows and print columns, we will see that, first of all, we have our rows array here, 0 to 127, and our columns array here, 0 to 7. So now we're going to start breaking these arrays down based on the letters in the string. So we're going to say for letter in P. So for every letter in this boarding pass, we are going to make a modification to one of these 2 rows. So if letter is equal to F, we know we want to get the front half of the rows. We want to get the first half of the rows array and throw away the back half. So we can do that by saying rows equal rows up until the midway point. So if we say rows 0 up until the midway point, and the midway point will be half of the length of rows. So we're going to say length rows divided by 2, like so. And that will create an integer here, which will be equal to the halfway point of the row. So now, if the letter equals F, it throws away the back half of everything left currently in the rows array and stores only the front half, which is what we want it to do. It breaks it down to that half. However, if the letter equals B, we want the back half of the rows. So we do the same thing, except we go until the end of the from the middle. So this here will take us from the middle, and we slice it with a colon up until the end of the array, just like so. So this is saying if the letter is B, we throw away the front half of the array. We don't need that anymore. Those numbers aren't important to us. We only need the back half of the numbers. But what that means is if we get F, it throws away the back half, keeping the first half of those arrays. But then we get the letter B, it will only look at those numbers we have left and then throw away the front half and keep that smaller chunk at the back. So every time we get a letter here, we're cutting down our array into halves to create slightly smaller arrays until we only have one item left. And then we're going to say if the letter is equal to R, we know that, no, let's go with L first. The exercise tells us that if the letter is L, we want, once again, the front half of the columns column. So if the letter equals L, we're going to do what we've already done. Columns equal columns split at from 0 up until the length of columns divided by 2, just like so. And again, for the letter of R, we're going to do the same thing, except we're going to go from the middle of the array and slice it up to the end of the array, just like so. So now, whenever we take a look at a letter in our pass, one of these arrays here will be split down and chunked down until we only have one number left in each array. And with that, we can then actually work out what our seat ID is. So we can say our row equals row 0, because when we get to this point, our row array will only have one value in it. So we're going to equal that to the single value that's left in there, and the same for column. Column will equal column dot column. It's actually going to be rows 0 and columns 0, just like so. So now we have, for every seat, we now know what row that seat is in and what column that seat is in based on the letters in the pass. It would have chunked it all down in the correct order. Okay, so I've only got a few minutes left, so we are just going to finish this exercise off now. We are going to take a look at what the seat ID is. So to get our ID, we multiply the row by 8 and then add the column. So we're going to, let me get back to my trinket here. Whoops. Okay. We're going to, so our seat ID equals row times 8. I'm going to have to go a little bit quicker here because I'm running out of time. Plus column, just like so. So, yep, I will copy and paste the code as soon as I'm done with this exercise. Right before I finish, I will drop the code into the chat so you can keep working on that should you want to. I'm very near the end now, though. Okay, so now we have our seat ID. We're going to append it into our seat IDs array, just like so. So now, if I print out at the end here our seat IDs, we will have a nice little array of 357 and 567. Is that correct? 357 is correct for this, and 567 is correct for this. So we know that this code is now working. The last thing we have to do is get the maximum value. So highest seat, we need to get the highest seat number in our array of seats. So we're going to do that just using the max function in Python, max seat IDs. And now we can print out your highest seat ID is 2 curly braces. And then we're going to format the string with highest seat. In this case, the highest seat was 567, which is correct. So now, before we finish this off, I'm going to get our puzzle input, which is all of these boarding passes, this gigantic list of them here, and paste it into our input. We have 743 boarding passes. And we are now going to run our code on this. Input.text would be great if it could be a variable, but the Python environment doesn't really allow for that. We'll talk about that maybe in a future video with input-output information. So if I run this, my highest seat ID is 838. If I type this in, do I get a star? Let's hope. That's the correct answer. So there we go. We now scanned all of these boarding passes. I'm going to link the... That's fine. I've linked the the code in the chat right now. My time is coming to an end, so I'm going to have to call it in just a few minutes. However, I am going to be hanging around in the chat afterwards. So if you want to continue asking questions about this advent of code, I'll be around to help. So I've taken a look at all of these boarding passes here, figured out where they are on the plane based on the letters, figured out the seat ID based on where it is, found the highest seat ID, and then printed it out. And we got the highest seat ID of 838. We're not going to do the second part now. I'm actually going to ask you to think about this for yourselves. The second part is, we need well done, CoderDojo. Fantastic. I'm really glad you found it useful. Thank you. Take a look at the second part. We have to take a look at all of the seat IDs and find out which one is ours by finding the missing number in the list of integers. And that's a fun one for you to tackle in your own time. You can do it in just a few lines of code, honestly. So I do recommend giving that a shot. But for now, that's going to be it. I hope you've all found this enjoyable and helpful. Well done to everybody that got their gold stars today. Fantastic job. I'm glad you got your gold stars. Take a look at some other. This is day 5. So take a look at some other Advent of Code exercises. Really get involved. There are, like I say, 250 puzzles on the Advent of Code. Is a challenge 5 or 4 about the seat IDs? That's challenge 5. So I recommend going and taking a look at some more, but my time is coming to a close now, so I'm assuming I'm going to be taken away from you all shortly. But if you have any questions or need any help, just let me know and I will be hanging around the chat. Thank you, everyone.
Oh, yeah, that was absolutely fantastic. I was on the edge of my seat. My head's aching a bit from colliding with all those trees. But I'm glad I'm going to be able to find my seat number in the boarding passes. Fantastic. Thank you very much.
That's no problem.
As I said, she's going to be in the chat if you want some help to get through the next stage or want to go back on anything she covered this afternoon. But now it's over to Jonathan to take us into the exciting world of Monte Carlo simulations. So over to you, Jonathan.
Thank you, Peter. Thank you, Aya. It's great to have some festive theme in when you're doing programming. So hopefully you can see my screen as well. Let me just try to share the screen again. So yeah, great. So we are going to talk about Monte Carlo simulation today. So what is Monte Carlo simulations, you would ask? So Monte Carlo simulations, sometimes called Monte Carlo method. So it's actually named after casinos in Monaco. So yeah, so Monaco is the south of France. It's right in the Mediterranean Seas, and it's actually called the Monte Carlo simulations because in the 1940s, the U.S. nuclear scientists, they need a code name, they need a secret name to name after nuclear projects. So they pick Monte Carlo because in the casinos, there are lots of randomness involved in the problems. So that's why they pick Monte Carlo simulations as a name to search to solve a nuclear research project. So yeah, it's an interesting backstory. So you would also ask, in the 1940s, they solved nuclear projects. So what would you do to solve? What kind of questions you could solve with Monte Carlo simulations today? So it's actually quite useful. So you can solve traffic jams problems like if you work on the TfL in London, you want to be as efficient as possible to manage all the traffic as well as the flows of pedestrians. So that's very useful. Weather system is another use case. You can use Monte Carlo simulations, and also finance, like the stock markets. What kind of investment strategies you would use? So Monte Carlo simulations are all over the place. But one very simple example is actually flipping a coin. So when you flip a coin, you would expect 50-50% for getting both sides. Also like rolling a dice, so is 1/6 the chance you will get 1 or 2 or 3 or 4, etc. So yeah, so the idea is when you redo the experiment over and over and over again, you will tend to get the result more accurately. So the example we are going to look at is actually quite interesting. It's like the first one of the first few Monte Carlo simulations example available. So it's actually estimating the value of pi as in 3.1415. So yeah, so how can we do that? So today is quite a rainy day. So in the themes of raining, so you can see the picture flashing in the background. So if you imagine right in front of you is a square of a field. So as the rain fall on the field, you can count how many raindrops falling in that field. And also, if you imagine there's a circle in the field as well, so it's the red dot in this case. So you can count how many dots fall in the circle and count how many raindrops fall in the square, but not the circle. So that's the blue in this case. So as you can see, there are more and more raindrops fall in this square. You can count the ratio between the blue drops and the red drops. And then by doing some math in the background, you can find out the values of pi. So that's quite amazing. So so yeah, we'll get to that very soon. So right here, I got a repository here, hosted on GitHub. It's actually a fork from mathematicians in Cardiff University. So I turned it into a Jupyter notebook and host it in the website so that you can play with it more easily. So if you go to the link, so yeah, if you go to the link, so you will see the binder. So binder is like a hosting company, so you can host any notebook on binder. So just wait for a bit, and then you will get to the Jupyter notebook very soon. So yeah, let me know if you have any problems. Get to the link, and then yeah, we can go from there. Okay. So yeah, once you're in, it's just a standard Jupyter notebook. So Jupyter notebook, I set up all the environments in the background. So all the Python library is all there. And where is the link? Maybe I can quickly share the link again. So if I just copy this link, okay, so hopefully you can see the link. So yeah, just click on the link and then just wait for half a minute or so. You will get to the Jupyter notebook. So a Jupyter notebook, so all the Python library is all there in the background. So just show you a few tricks. So yeah, when you do Control Enter in a cell, so say for example, I'm on this cell. If I do Control Enter, it means you want to execute this bit of Python code or code. So when you do that, what it does is it will load a Python library, and then this library will load the image. So this GIF is a part of the repository. So basically what it does is when I do Control Enter on this cell, it will load these pictures. And another trick you could do is you can insert another cell above or below. So maybe I can try insert above. And then in this cell, you can just type whatever Python code you want to do. So maybe 1 + 1. And if I want to print this out, hopefully I will get 2. So yeah. So yeah, that's actually quite useful. So you can try to debug your Python code. You can experiment different code as you go along. Okay, so we want to solve this mysteries of the value of pi. Okay, so there's a few steps we need to follow. So the first step is we need to import all the Python libraries and all the functions so that we can run the simulations. So we want to execute this Python cell. So let's do Control Enter. So when you do Control Enter, it will go blue, and then there will be a number show up. So if you see that, it means Binder has executed the Python cell in the background, and then you can go forward. Okay, so we've done the libraries. Okay, so now we need to create a raindrop. We need a raindrop so that we can run the simulations, right? Okay, so I try to wrote some instructions in the comments as well. So hopefully, with some guidance, you will get to the answer. Okay, so the first problems we need to solve is we need to build the functions. So this function is called rain underscore drop, and this functions what it do is it will return a coordinates as a list. So we need x and y. It has to be a list, and x and y need to be within minus 0.5 and positive 0.5. Okay, so how can we do it? Okay, so there's a hint in there as well. So you can use a random library. So random, random will return, random will return a float number within 0 and 1. But what we're looking for is we're looking for minus 0.5 to positive 0.5. So how can we do it? Okay, so I think we're gonna take it easy. I don't want to rush anything, so I'll let you have a crack first. When you are done, maybe you can leave a comment in the chat, and then I can go to the next part. So when you experiment with your code, you can try execute this cell. So you will see 4 here. It means it has executed in background, and then you can use the following cell. So basically, it's print raindrops. So you can experiment your algorithms like this way. So say for example, if you do this, if you execute it, and then what it will do is it will print out 1. So I'll let you have a crack. Give me a shout when you're done. So yeah, just leave it on the chat when you're done. Okay, so random return 0 between 0 and 1. But what we need is minus 0.5 and positive 0.5. And it has to be a list. So what should we do? So yeah, maybe we can start with just printing now random. So yeah, it's within between 0 and 1. So that's expected. Yeah, let me know when you're done. Just leave a message on the chat, and then I can go forward. So maybe we can just try with returning a list. So a list is within the square bracket. So if we do this, how about this? So so it's returning a list with two numbers in the list. Okay, so that's expected, right? Between 0 and 1. But what we need is between minus 0.5 and positive 0.5. So one way you could do this is you could do it just take out just take out 0.5 from those numbers. Yeah, so if I do it again, yeah, so I have a negative number here, and I have another positive number here. Let me just try a few more times. Yeah, so that's expected. Okay, but if you pay more attention to the instructions, so we define length of field to be 1. So length of field is the diameter of the square of field. So as you can see here, it's between -0.5 and positive 0.5. But the length of field can vary, so it can be 10, it can be 100, it can be thousands, but in this case it's 1. So I think we need to have a length of field in this as well. So maybe we can just times it by length of field. So random minus 0.5 and then times length of field. Okay, because length of field is 1 in this case, so you will always have 1. But if you change that to something else, the answer will matter. Okay, so let's just make sure it's still working. Okay, cool. So what these functions will do is it will just generate a raindrop for us with within the field. Cool. So the next steps is we need to check where exactly the rain drops in the field. So what it does is it will take in the first argument is a point. So the point is from the raindrops, and raindrops it return a list of 2 numbers. So what it does is it will take it in, and then these functions need to return either true or false, depends on where exactly the point is in the circle. Okay, so we need to think about a little bit of geometry and trigonometry here. So I got a link ready here. So as you can see, this is a circle. Not sure if you are familiar with the equations of a circle, but the radius, so the ellipse of the circle depends on x and y, and it's always follow this equation. So it's the Pythagorean theorem. So your x squared plus y squared always equal to r squared. So if we follow these logics, any raindrops falling in the circle, x squared plus y squared will be smaller than r squared, which means like in this region, so x squared plus y squared will be smaller than r squared. And if a raindrops falling outside of the circle, x squared plus y squared will be bigger than r squared. So we can maybe we can use this logic to implement the functions to return true or false. Yeah, okay, so if we go back to the notebook. Okay, cool. So I will just give you maybe a minute to let you have a crack first. Yeah, let me know in the chat. Yeah, let me know in the chat when you're done. So yeah, these functions need to return either true or false, depends on where the point is. Is it inside the circle or outside the circle? So also similar to how we did it in the past, so you can execute these functions. So if I do a control enter here, and then I can do a control enter on the following cell. So right now it's printing an empty list, which is not what we want. So we need to implement the logic here. And then you can quickly have a test on this cell. Oh, okay. Cool. Okay, so if we maybe we can just quickly look at points. So point so we believe point is a list, and there should be 2 numbers in the list. So we can just quickly check if that's the case. So if we do that, okay. So its point in circle is 1 1, so it's printing us 1 and 1, and 0.5 and 0, 0.5 and 0, 0 and 0.5. Okay, cool. So that's what we thought. So if we implement the logic, so we can do point 0. So what we're interested is we want to implement this logic. So we want to have square. Okay, and then smaller than r square. So in this case, what is your radius? So we have length of field here. So length of field is actually your diameter of the circle. Is so we need to divide that by 2. So diameter divided by 2. So length of field, and then divided by 2. So this becomes your radius, and radius square. Okay. So we can comment out this bit. Okay, so the first one should be false, true, true. False, false, true. Okay. And also this is within a list. So that's not what we want. We want to be just false or true. So maybe we need to take this out. Also, so let's just quickly try this. Okay. And we also need a equal sign here. Okay. So cool. Everything looks alright. So we got a point, we got a raindrops. We also have a functions to determine where exactly is the raindrops. So maybe we can start doing some simulations. So in a simulations, you want to define how many raindrops in the simulations. So it could be 100,000, etc. So these functions have the first variable is as number of drops. It's 1,000 at the moment. So the first task is we need to just set up a few things. So we want to iterate from 0 to the number of drops we want in the simulations. So we're going to use the for loop in this case. So how should we do it? Like what's the correct way to set it up? And when you are done, you can have a look at the second problems in this function as well. So we want to assign the raindrop to a variable called d. So remember we already have a function called rain underscore drop. So we can just take that functions and then assign it to d. So someone asked what was the first box returned. First box. So the first box should return, I assume it's the raindrops functions. So so this raindrop functions will return a list of 2 numbers, and that those numbers should be within minus 0.5 and positive 0.5. Okay, so we want to iterate from 0 to number of drops, right? So we're using a function called range. So maybe we can start from 0 and then iterate all the way to number of drops. Okay, so number of drops by default is 1000. So 0 number of drops, but that's actually range. You don't necessarily need to define 0 here. If you leave it blank, it will by default it will be 0. So you can leave it blank. Okay, and the next task is we want to assign raindrops to be variables called d. So d, so we can just call rain underscore dropped. Okay. So maybe we can quickly have a look at raindrops again. So raindrops, it takes in one variable, but by default, length of field is 1. But for the sake of good practice of programming, we should also pass in this as part of the simulations. So length of field, by default, length of field is 1. So by this point, length of field become 1. So this is correct. Okay, so we set up the for loop. We define D as a raindrops. So now we want to have, there's another variables called number of drops in circle. Okay, so these variables, it got to be increased by 1 if this statement is correct. So what it does is it will look for the functions we just wrote, checking if the raindrops is in a circle, and if this statement is true, it will execute this bit. Basically, it will append the raindrops to a list, as well as increase the number of drops in circle by 1. So if we do something like this, it will work. But actually there's a better way to do this. So in Python, if you want to increase a variable by 1, you can do like this. So basically increase itself by 1 whenever it gets to this point. So if this point of in circle is true, it will execute this bit. Otherwise, it won't. Okay, so the next bit is a bit more tricky. So if you think about it, you want to work out what is the value of pi. So the area of the circle is pi r squared, isn't it? And the area of the square is your diameter square. So it's d squared in this case. D is also 2r, so basically it's 4r squared. And then if you think about it, the area of the circle divided by the area of square, it should be equal to the number of drops in the circle divided by the total number of the raindrops. So it's a bit confusing. So if we just look at the animations again, so the number of raindrops in red, which is the area of the circle, so area of the circle divided by the total number of the raindrops should be equal to the area of the circle divided by your square, which is what we do here. So this statement is definitely true. So area of circle should be relative. It should be a ratio of a number of drops in a circle divided by the total number of your raindrops. And if we substitute those variables into these equations, so pi r squared divided by 4r squared, which is pi in this case, and then we can multiply the right-hand side by 4. So pi becomes 4 times number of drops in the circle divided by total number of drops, which is what we do here. So it looks very confusing when you look at this line, but hopefully the explanations helps. Okay, so let me just quickly execute these functions. Okay, so we can start the simulations, I think. Okay, it complains about number of drops is not defined. Okay, so maybe we can start with number of drops to be 1, maybe 10, just to make sure the simulation framework is there. So, okay, cool. So it's fine. So it's basically just printing out the first in the list and the second element in the list, which is number of drops in circle and then number of drops. Okay, so there are 6 drops falling in the circle and there are 10 drops in total. And what is the value of pi? Let's find out. So the value of pi, the estimate to be 2.4. As you may know, pi it meant to be 3.1415. So 2.4 seems quite it doesn't sound correct to me, but we can just quickly make sure everything is working. So visualizations, we can quickly check the visualization is working as well. So this basically is another animations. So the blue drops is the drops in the circle and the black is drops outside the circle. So you can see 10 drops doesn't feel enough to have a meaningful estimation for pi. Yeah, so one way we could do it, we could increase the number of drops in these simulations. So if we do, maybe try with 100. Let's go for 500, shall we? Okay. So in this case, there are 365 falling in the circle and 500 in total. So we get 500 in the total. So yeah, that's what we thought. Let's have a look. Okay, 2.92. And just quickly check this. Okay. Yeah, kind of makes sense. And pi estimate to be 2.92. That's interesting. It's still not 3.1415, but it's getting closer. We were getting like 2.5 in the last run. Okay, so let me just give you a few minutes to play with this, and then I can show you the result later on. And if your stock didn't manage to get any of the functions working as well, let me know. I try to help you with those as well. Yeah, for those who would like to know more about Monte Carlo simulations, I think if you click on the very top of the page, there's a visit repo button. So it will bring you to a GitHub repository. And then hopefully the README is quite useful, so you can just go through it. You can also run the code, and then you can experiment with different number of drops in the simulations. In step 3, do we need an equal sign? So yeah, we do need an equal sign because if you look at the circle equation again, so if x squared plus y squared equal to r squared, it means the raindrops fall right on this line, which is part of the circle, so we can have an equal sign as well. Okay, so yeah, let me know if you have any problems or any troubles getting the functions working. Okay, so A very important element of Monte Carlo simulations is the randomness itself. So for very complicated problems, like the traffic problems, we need the variables, in this case the number of drops and the where exactly the raindrop is, which is this functions. So we need those variables to be as random as possible. It means it has to be unbiased. So an unbiased variable is a whole. It means like a whole range of values. So in this case, it has to be random, evenly distributed between minus 0.5 and positive 0.5. If we have raindrops very concentrated on around 0, the simulation is not going to work. So we need to believe these random functions return something random enough for these simulations. So in this case, it's actually okay because that's what it does. But if you tackle another different kind of problems, you have to make sure your random functions is truly random. It's not focused on a very narrow of range. Otherwise, your simulations is going to fall apart. Okay, so you may ask yourself another question as well. So we have 500 drops of raindrops in these simulations, and we have 2.92 as pi. So you will ask yourself how many number of drops we need to have accurate number. So hopefully I can answer that later on. So you can just put a very large number in this simulation. So say 10 millions or 100 millions or trillions. So more as the number goes up, for sure you will get a better answer as your estimations. But these problems we're trying to solve is quite easy. If you do the simulation for 100,000 millions of times, Python will do the computations, so it will calculate the number for you quite quickly, very quickly. But if your problem is complex, do your simulations for millions of time may not be a good idea because it may take years or maybe tens of years or maybe your entire life to run your simulations. So sometimes it's not a good idea. So it's a fine balance between how many number of simulations you want to run. Okay, so if I just share, if I just go back to this page, okay. So I have a example. So it's basically 500 drops of rain, and you can see. So your y-axis is your number of iterations. So for the first few iterations, it's jumping up and down, and as it go along, it's roughly 3.2. So that's not ideal, right? So how about 10,000 drops? Okay, so 10, so yeah, that's 10,000, right? So 10,000. Okay, so yeah, so and the red line is the true values of is 3.1415, I think. Yeah. So yeah, fluctuate a bit, and then it goes towards 3.1415. So that's quite ideal. So I try another run with a million drops as well. So that's quite a lot. So if you look at the result, you quickly see it basically converge to the real answer very quickly. So around this point, which is about 2,000 times. So by 2,000 times, you get a fairly good estimations already. So in this particular examples, you don't need to do it for 1 million times. You just need to do it for, I would say, 3,000 times to be on the safe side. So 3,000 times, you should get a pretty good idea. So let's try that. So 3,000 times. So if I do this, it will return an answer straight away, so it's pretty quick. Okay, still not ideal. But if we look at, okay. So how about if we try this? Oh, okay. I think there may be some problems in the code. Let me see if I can spot those. Okay, maybe I can quickly share the other screen. Okay, hopefully you can see my PyCharm windows. Yeah, so if I just run this simulation for 500 times, so it's actually doing the simulations in the background. So we got an estimate of 3.128. So maybe we try it a little bit more. So in this case, let's try 3,000 times, as we said in the past. Okay, so 3.138 is pretty good. So just be on the safe side, we just increase it to maybe 10,000. It may take a bit longer, but we want to be confident. So yeah, 3.139. So it's fairly close to 3.14. Okay, so let's go crazy. Let's try to do 50,000. Okay. Okay, so yeah, 3.139. I want to show you the result as well, so let me do that. Okay. Okay, hopefully you will see my browser as well. So yeah, so that's 50,000 number of drops in the circle, and that's the result of the estimations. So yeah, around 4,000 runs, we have a fairly good estimation already. Cool. Hope that's useful, and you have a good understanding on Monte Carlo simulations. So yeah, as I said before, Monte Carlo simulation still used in our daily life. It's fantastically useful in many complex problems. So hopefully in the future you will try to use some of the techniques we learned today to solve the problems. Thank you. I think go back to Peter or Richard.
Jonathan, thank you so much. This was just a beautiful, elegant exposition and fascinating with so many applications. So thank you very much. That was great. And Richard, now over to you and Ozzy. Hi, Ozzy. Hi, hope you had a great Christmas.
Yeah.
What did you get? Anything special?
Lots of food.
What was the number one?
Probably this game expansion pack again.
Cool. Anyway, thank you for prizing yourself away from the screen and console to help Dad with our next session. So, Richard, over to you.
Great, thanks, Peter. Hello, everyone.
Hello.
Today we're going to do some more machine learning. So, if you were here on the last stream, you might remember we looked at a simple image classifier. So we looked at how to use machine learning to identify certain images, and we found dogs, and there's that weird animal, that thing. Yeah.
Like the lizard thing.
The lizard, yeah, the lizard that we were identifying.
The dog that was a tennis ball.
The dog was a tennis ball, it was. This time we're going to do something slightly different, and we're going to train our own machine learning model. So rather than using one that exists, we're going to train one ourselves. Now, the model we used last time had been trained on loads and loads of different images. We're going to do a very specialized one today, and we're going to train a machine learning model to recognize handwritten numbers. So, you know, when you write down number 6 or number 5,
Yeah.
if you're like me and you've got really messy handwriting, that can be quite hard to decipher. So we're going to try and train a machine learning model to read and recognize handwritten numbers. So just like last time, we're going to be using Google Colab again. So if you'd like to work along with us, there's a starter project that has some really useful code in there. So if you go to rpf.io/ml3, that's an L in there for machine learning. So rpf.io/ml3, that will take you to the Google Colab project that already has some code in there for you to save you lots of typing. So let's at our screen. Yeah, here's the Google Colab you'll find at that URL. As you can see, there's some code in there. Mainly, it's for displaying some graphs later on. So rather than have us type all this stuff in about drawing axes on the graphs, it's just already added in there for you. And also right at the top there, you can see there's some libraries that we're importing, which we're also going to use there. So just like last time, the machine learning library we're using is TensorFlow, written by Google, because there's lots of good examples of that, and also some helpful data, which we're going to see. As usual, if you get stuck or have any questions, shout out in the chat. There will be mentors in the chat working to help you, but we'll get stuck in straight away. So if you scroll down through your Google Colab to the first empty cell, you'll see there's a thing there with a comment on it, load the MNIST data you'll use to train your model. So that's what we're going to do first. So actually, before we start, one thing we need to do, if you go to, what we need to do is to take our own copy of this Colab space. So if you go and click on File, and then do Save a Copy in Drive, that shall make a copy of that one, because that's a read-only version otherwise. And there you go, you can see now it says copy of number of recognition starter. Maybe we might want to rename that just so we know it's ours. ZZ. Right, great. Hit enter, I think. Great. And that's now saved as our own copies. We need to do that first. Now, if we go back down to that first cell, we need to get some data. Now, in order to train a machine learning model, what you normally have to do is give it lots of data. So if you're training a model to recognize vegetables, for example, you'd have to take lots of pictures of different types of vegetables and feed them into the model. Because we're doing handwriting, we could spend ages getting lots of different people to write down numbers, and then we could take photos of them, and then we could put them into our computer. But luckily, we don't have to do that because Google's already done it for us. So we're going to use a set of data that comes with TensorFlow. Let's call it numbers. Yep. I've already done it. Great. What was I? Yeah, so let's call it numbers. We're going to call our data set numbers, and we'll say numbers equals, and we're going to say TF for TensorFlow dot keras got data sets, got MNIST. And MNIST is a database basically of all these handwritten numbers that other people have done for us. So we're going to call it numbers, and then we need to load it in. And when we load it in, we need to load it in and create some data that we're going to train it with, and also some data that we can test it with. And we need to do that by setting it as some tuples. What's a tuple, Ozzy?
Isn't it like a list?
It is like a list. So in Python, where you have lists are in square brackets, tuples are in round brackets. And the main difference is you can't change tuples. You can't add things to them or modify. And that's fine with what we want to do. So we're going to do open round brackets. And we're going to create our training images. So we want to have a set of images for training. And then we want the labels. So that's whether this is a number 1, or number 2, or number 6 or something. And then we want to do another comma. We want to have our validation images, which are the ones we're going to use to check. The point of having validation images is so that we don't only train our model to work on the data we're training it on. And that's a common problem with machine learning, is you train it on data, it works perfectly on that, and when you give it some other data, it goes wrong. So as well as the validation images, we want validation labels. You see we've got 2 tuples there, and then we'll set that to be numbers dot load underscore data. Nothing there. So is there a missing underscore? Is there a missing underscore? Yeah, there is. Well spotted there, Marcello. Thank you very much. Nicely done. Great. So if we run that now by clicking, actually, let's go right to the top, and we'll click on runtime at the top, and we'll run all. So that will do all our imports as well, and run all those functions for us up to where we are now. You can see there, it's done the imports, run that blank cell, doing those programs we use later. And we've done everything else by now. Yeah, great. And then you can see that it downloaded that data. So let's just have a look at that data to see what's in it, so we can get a feel for it. And because we've imported matplotlib, we can use that to display an example of it. So let's do that next empty cell there. Let's do plt for plot library.imshow for show images. And we'll just pick one of the ones at random from our training images. Training images, let's just pick the first one, so element 0. And we just need to say, because these are grayscale images, these are in grey, spelled the American way. Okay. So just run that individual cell there. There we go, and then there you go. So that's a number 5, isn't it? And let's just check that. Let's underneath the line there. We'll do print the labels out. Yeah. Training labels. I think the people who've got the problem, Marcello spotted that earlier on. There was a missing underscore between training and labels. Yeah. So you should have training underscore images and training underscore labels.
There should be underscore between like all both the words of training labels validation.
Yeah, yeah.
Print training labels.
So print 0, 1 is there as well. Tell us that's actually labeled as a 5, right? Yeah, it's number 5. Let's just pick another one at random. Let's pick, I don't know, like 33. Have a look at that, what number that is, and we'll do the label for 33 as well. Yeah. 9. Okay, so you can see we've got a whole bunch of. Look at this one there. Okay, yeah. I'm not sure. We could have a look. Look at the length we want to do. 27. There's a whole bunch of those images in there, and that's what we're going to feed into our model to train it. Now, obviously, it's a machine learning model, so it doesn't really, the algorithm doesn't look at the picture. It wants to look at it at numbers. So if we actually now, just underneath that line there, let's actually print out one of the images. We're not going to plot it as an image like we did with the plot.imshow. We'll just actually print that on there. Now, what number? That was number 0, wasn't it? Which was a 5. if you scroll down there, you can see like most of these values are 0, and then there are some that are high numbers, like in 200s. And if you like, just make the text a bit smaller on the window for a second, zoom out a little bit. Yeah, and again, again, again. Can you see where the numbers are? Right, there's like a number 5 there drawn out. Can you see how that's worked? Yeah, right, you can show you the mouse. So there's a 5, right? If you squint, you can see that basically all the zeros are where there's the white background of the image, and all the higher numbers are
it's got kind of
the
like,
white. Sorry, all the zeros are the black, and the higher numbers are the white, right?
it's kind of taking it from here as the edge. Because if you look at the end of this bit,
Yeah,
is
that's
over here.
why it's scrolled over. Yeah. Right. Okay, let's zoom back in. So you can see that's how the computer, how the algorithm is seeing the data, and it's almost how we see it as well. Right. So there's one thing we need to do. One final thing we need to do. If you go down to the next empty cell, TensorFlow is expecting our data, instead of being between 0 and 255, it wants it to be between 0 and 1.
So it's either white.
Right. So how can we change our data that we saw there into?
So if anything divided by
Yeah.
anything divided by 255.
Will work. Right.
If it equals 0, then you make it as 0.
We don't mind as long as it can be between 0 and 1. So it can be a decimal. So it can be 0.6. That's fine.
Oh.
So if we divide all our values by 255, we'll get that right. If the value of 255, it will be 1.
Yeah.
If it was anything less than that, it's going to be a decimal between 0 and 1. Yeah. So we'll take our images and we'll just divide them. Make sure we do it as a float. Yeah. Between 255.0.
Do that for training me.
And not the labels,
Oh,
the validation images. The labels are just our, like what number it is. Jim Huggett, you're saying you have this problem. You've got OM show, it's IM show, plot.im show. Look. Down. Yeah.
Here's IM show.
Plot.im show.
Yeah.
The image show. I should fix that.
Okay.
Great. So yeah, let's run that cell. That will do that division for us. I love the thing about Python lists that you can just divide the whole list by one number rather than having to do each one individually. Right, so now we're going to build our model. So I'm just going to talk a bit about how models work. It will kind of explain what we're doing next. The model we're going to build is a neural network. Can you think of where there's a neural network? Or there's two, yeah, in our brains, or my brain anyway, has got a neural network in it. And this model is called a neural network because it's a bit like how a brain works. It's a very simplified brain. In machine learning, we call the neurons in our brain nodes, and they're divided into layers. And so the model we're going to create is going to have a number of layers, each doing different things. And in machine learning models, you always have an input layer, which takes the data in, and you have an output layer at the other end, which feeds the data out. And then the number of nodes in between that are the things that do all the calculations. So our model is going to have 4 layers. The first one will take our image in, and it will flatten it out. So rather than having that array of numbers, we'll just have one big long list. And then the second layer will take those numbers, and it will try and create some rules about it. So it might look at the data and say, if there's a curve in the top right-hand corner, then it might be an 8 or a 3. And if there's like a straight line going this way, it might be a 6. And it will build up a whole bunch of those rules. And then we'll have another layer that will take all the output of those rules and try and combine them together. And then finally, we'll have a final layer, which will be our output. And that will give us, will basically give us how confident the model is that it's found a particular number. So it might say, I'm 10% sure this is a 1, and 50% sure it's a 6, that kind of thing. So what we need to do now is to create our model. and we're going to create what's called a sequential neural network model. So we'll call it model, that's the name for it. And we're going to use the TensorFlow model, Keras. It's not sequential. Capital S, yeah. Sequential, yeah. Sequential. And then we need to give it a list. And that list is going to be our 4 layers. So our first layer is going to be our flattening layer. So we're going to call TF again. I'm not sure you're going to work with that point line in between there. I've got to do it on the first line. Well, it might get messed up. TF, Keras, layers, flatten. And then we're going to say it's an input. And we need to tell it what our images look like. And in this case, they're you remember when we printed out our image, it was 28 pixels by 28 pixels. So we need to do it 28 by 28 pixels, have a comma at the end. That's our first layer. Our second layer is the same thing again, tf.keras. I know that helps, unhelpful, because it blocks the screen, isn't it? In this specify. It's going to be a dense layer. We're going to give it 500 nodes. So there's going to be 500 rules basically created in there. And then we're going to give it a thing called an activation, which I'm going to talk about in a minute. Activation, and we're going to use the ReLU activation. We've got that in a minute. Let's just create the model first.
Just leave it on. Yeah, I'll just leave it like that.
Okay, cool. That's our first 2 layers there. I'll talk a bit about ReLU now then while people are doing that. So ReLU is just the default activation layer. And basically what that does is it looks at the rules that have been created and decides whether they're any good or not. It might look at them and say, actually, this rule is giving too many wrong answers, so we're going to ignore it. I won't pass that on to the next layer. Or it might say, hey, this rule is really good, I'm going to activate that in the next layer. All right, let's create our next layer there. It's almost, you can probably copy and paste that line in because it's the only thing we're going to change is the number of nodes.
Math,
it's math, yeah. Sorry. Yeah. Just change that to 300. Yeah. And then our final layer is the output layer. That looks almost the same again. Yeah. And this time it's only going to have 10. Why is it going to have 10 nodes? Only 10 outputs.
Because there's only 10 numbers.
Yeah, exactly. There's only 10 possible numbers, right? 0 through to 9. And this is going to have an activation called softmax. And basically, softmax will give us a percentage. It will say, I'm 50% sure it's this. Yeah. And you're going to square brackets, close that. Right. This is hard to type in without Python messing up the formatting. So just run that and check it doesn't give us any errors about our formatting. No, let's skip. Nice.
What is the rationale?
The rationale between 500 and 300 is when I was testing it, that seemed to give me good results. So you could absolutely play around with those. You could add in more nodes. You could add in more layers. This just works quite well and also doesn't take too long when we need to compile the model, which is another thing I thought was quite important. But you can definitely tweak all these. And if you were finding that your model wasn't working very well, these are the kind of parameters you might want to adjust later. As I just mentioned, next we need to compile our model. Basically, compiling it is preparing it for training. What we need to do is tell it how it can get better. Machine learning is all about repetitively testing things and trying new things. So I'm just asking what ReLU was. So ReLU is just the default activation layer that comes with TensorFlow. These things are quite mathematical. ReLU is basically how the model decides whether or not to take rules it's created in one layer through to the next layer. Anyway, so compiling the model, we're gonna define an optimizer, which basically tells the model how to get better at itself. And it will do that by having what's called a loss function. So a loss function is essentially a measure of how good or bad you were at doing the thing you were trying to do. And we're going to use this model and tell it to keep trying to make that loss number as small as possible. Because we're doing quite a simple classification, we can use some quite simple approaches to optimization in here. If you really want to spend a lot of time reading about these, there's loads of stuff you can read about using optimizers. We also need to say how many batches we're going to work with. So the way the model works is it will take like 10, we're going to say 10 images, run those through the model, and then try with another 10 and keep doing those in batches. And it will keep going through the data again and again. And that's called epochs. So we're going to define how many epochs it is as well. So let's just start writing that hopefully make more sense. So we're going to say model.compile. That's what we're doing. We're compiling our model. And we need to specify what optimizer we're going to use. We're just going to use the Adam optimizer, which is a pretty simple optimizer. Again, there are loads written there. I'm guessing this one was written by someone called Adam. I'm not sure. And then we need to specify our loss. So we're going to say with loss, we're going to use, again, a thing called sparse categorical cross entropy. And I honestly don't actually know what that is.
Yeah,
it
fills it in.
It fills it in for you. So
use the one without
it. Yeah. And you have to give it open brackets, curly brackets at the end there. It's a function we're going to run. And we're also going to define some metrics that it's going to print out for us to show us how it's progressing, and we're going to get it to print out its accuracy, because that's what we're interested in. We're interested in how accurate our model is. Yeah. And then after that, let's just print out the summary of the model when it runs. And it will just tell us some stuff about what we're doing. Summary, yeah. Intro like it is now. Right, run that. Let's see what I type on that. Yeah, there we go. And that's showing our model there. And you can see there's the 4 layers there. There's our flatten layer, our 3 dense layers. The middle 2 have got 500 and 300 nodes, and the last one's got 10 nodes. Great. So now we're ready. We can actually train our model. So training it is sometimes called fitting, because you're fitting the data to the model, or rather you're fitting the model to the data. And we just need to tell TensorFlow the things I mentioned before. So how many batches we want to use, and so how many epochs we want to have, so how many times we're going to run through the model, and what the batch size is. So normally in these things, around, yeah, just get to type that one in there. Hopefully, when you type, you should, as Ozzy showed you, the sparse categorize cross entropy bit should be auto filled in for you, because that's a horrendous thing to type.
Use the one without the underscores.
One with that, yes, use one without the underscores. Yeah, I'm not sure what the one with the underscores is. Yeah. Yeah, so we're going to run it through. We're going to create a variable and assign that to model.fit, which is basically the function to fit to the model. We'll scroll down a bit. So we can say history, let's call it history, that's what we normally call it. History equals model.fit. And we're going to tell it, we're going to use these training images. Click on the blanks. Yeah. And then we need to give it our training labels. Probably a way of turning off all that helpful stuff on the screen. Just click on the white space. Oh. No, yeah, comma. And then we need to give it the batch size. Ignore all the helpful stuff. Batch size to 100. Yeah, and epochs is 10, so we're going to run it through 10 times. And we need to tell about the validation data, which is the thing I say. Once it's fitted to the model, it will try it with some other images just to see how good it's doing. Make sure that it's not only being trained on the training data, but it's not only going to work on the training data. that again. Yeah, there we go. It's running. There we go. So now you can see this is the model now actually being trained on the data. And quite the nice thing about these small images of numbers and stuff is they train really quickly. Some of the other you're also training on images. They can take quite a long while, but these are rattling through quite quickly. And as you can see there, if you just scroll along a bit onto the right, so you can just see what the accuracy values are. I think you're right first time with that was. Yeah. Wait, just make your screen a tiny bit smaller, maybe. You can see that. Yeah, there you go. You can see the accuracy.
It's getting bigger.
It's getting better. Yeah, it started off at like 88%, and now it's down at 95%. So 99%. Where did you get a typo on, Marcello? Which bit? Yeah, which thing you're running? Is that the fit in the model? Usually the model fit.
Is it because that last? No.
You've got some weird thing in yours. Yeah, you've missed out the validation. No, that is right. Okay, just scroll on weird on the chat. Did you definitely divide your training data and your validation data by 255 to scale it to 1 to 0? Because that might be why you're doing that.
Mm-hmm.
Yeah, VSK 254. That looks like you've missed out a bracket at the end there, where the end of file while passing. There should be. Yeah, that's it. Yeah, that should work then. Just go down to show the some bracket at the bottom. Yeah, just there. You point the mouse there. Yeah, there's a bracket there. Yeah.
You spelled training wrong.
Yeah. VSK 254. You've got training.
Yeah, you've got training. Somewhere training is. Yeah, look, it's here. It's at the.
Oh yeah, there. Model fit, the very first one. Training. You've got training.images as well, rather than training underscore images.
You shall see that.
This is got stars. Looks okay. The syntax error might be you've missed out a comma on the line before it,
yeah,
maybe?
You might have missed out. You might have missed out this comma here.
So that is, although it's on 3 separate lines, that's all one Python function, essentially, the compile function running. You need to make sure you haven't got like a missing quote mark around Adam on the line in front. That might cause a syntax error as well. All right, cool. Great.
Okay, cool. So we've got our 10 ones trained.
We've trained our model now, so now we should be able to
test it.
We're going to test it, but before we do that, let's just have a look at something because we put it in there. If you remember, right at the very start of the Colab, there was a whole bunch of functions about plotting graphs and stuff. Let's just, yeah, those ones there. Let's just run one of those functions now to look at how the model works. Yeah, so we'll do plot underscore accuracy and loss. What does a syntax error actually mean?
Isn't it a spelling or grammar mistake that stops program from being able to actually run?
Yeah, exactly. Yeah, so basically.
It's a grammatical mistake.
Yeah, it's the equivalent of a grammatical mistake in English. So Python will expect things to be laid out in certain ways. You know, always to be an end square bracket when you've got a start square bracket, or things to be separated by commas, or there always to be a single quote either side of a string. And if you miss one of those out, Python goes, oh, hang on, I didn't see the end of that string, or I didn't see the end of that list, and it calls that a syntax error. Yeah. Let's just run that. Should put some graphs for us, hopefully. Yeah. So this is just basically showing what the model did. And you can see in here the training accuracy goes up really quickly with this model. You start to head up towards 100% really quickly. I'll just go back to the model.fit line. Yeah, there you go. Don't forget don't forget the final bracket on the end. Don't forget this final bracket here. But those graphs, you can see the training accuracy went up, and the validation stuff stayed flat, which is what you want it to be. You want it to always be good with its validation data. So now we've got our model. Let's see whether it has worked. So go down to the bottom. If that's okay now. So yeah, just delete that if you like. Let's try it on an image. So we've also got a function which is called predict image, and that's like the function we used last time when we were doing the image categorization. That will take an image on the internet and run it through our model. So there's an image we've got on a short link called http://dojo.soy/num2, and guess what number that's going to be?
2.
It could be, yeah. Just run that and try it, see what happens. http: you missed that slash.
Oh, yeah, it's done.
Yeah.
Model prediction numbers 2.
Great. So that's a really obvious 2, right? That's a really clean 2, and it said that it was a 2. So that looks like our model's working. Let's try it with some real handwritten numbers. So I think this is going to work. If you go to a new tab and go to autodraw.com, as in automobile. Like I did earlier, so let's just bucket fill all of that. Oh no, yeah, click on that little thing there, that'll clear it all off. Let's bucket fill to give us a black image, change the color to black, and then change it to white. And then draw a number. What's that?
5.
5, okay. All right, then click on the little lines at the top and do share. Right, and then right click on. I didn't think copy link worked. Do copy image address there, yeah. And then go and pass that back in to our thing. Yeah, I think this is going to work. Yeah, try on that. So I think you need maybe to have some thicker white in there. Let's try that again.
Yeah.
That was too thin, I think. We blank it all. Okay. Right, let's see.
It's a rubber.
Let's revert it. Do share again. Yeah. Three.
What's that 3 then?
Well, I don't know, because it's got a bit there. Just try and do it like a not one that was written by a 2-year-old. Yeah, try and do it like a reasonable number. Okay, that's good. Yeah, nice. Like that.
Sure.
What do you think there? There we go. Right, that works. It's nice. Right, cool. And there we go. We've got a machine learning model that we trained to recognise even Aussie's handwriting.
Yeah.
Nice. So if you want to have a go with it, with training your own, the website we used was that one, autodraw.com. That's a nice way of getting some simple white on black images for the model. Has anyone got any questions or anything about machine learning? You could obviously, if you wanted to train your own machine learning model to recognize anything, you could do it in exactly this way. All you'd have to do is provide it with plenty of images and make sure they're labeled. So basically create them in a set of folders with the names of whatever it is you want the labels to be. And then you could run through this process and train the model that way. Okay, well, that's us. That's us finished for today. I'm going to hand back to Peter now. Looks like he's ready. Time for stream.
Hi, Richard and Oz. Thanks so much for fascinating visit on machine learning and recognition. It was great, and I think everyone will have had their appetite whetted to try more. So thanks very much. And that wraps up our afternoon. Hope you've had a great time. I've certainly loved every minute of it. And so I'm just going to end by wishing everyone an enjoyable rest of the holidays if you're taking the next few days off, and a happy and healthy new year for 2021, and hope everyone finds it better and we get released with vaccinations from the terrible curse of COVID-19. So take care and stay safe, everybody, and enjoy your coding. And we hope that we'll be able to meet in person at Penryn Road at Kingston University before too long into 2021. Bye.
Bye.
Bye.